Hello. We're going to be starting our third examples on calculating the area under a graph. Remember, if you have any questions, you can email me at absolutemathemax@yahoo.ca. So let's start with our example. It reads, find the area bounded by the curves. And we're lucky enough in this problem that the curves are already given. We already see right away what area we want to calculate. We want to calculate, I don't want to draw too much in here, but all of this area, right? And remember, in the last video we learned that we could actually flip. Normally we have rectangles that were vertical, but in the last video we learned we could flip them so that they're horizontal, because we can't have the bottom and the top of our imaginary rectangle touching the same curve or the same function. So in this problem, I want you guys to look at it and decide what would be the best rectangle to use, the vertical ones or the horizontal ones. This one's a little tricky because it looks like you could maybe even use both, but let me show you why we probably can't. So if we check to see if we can use horizontal ones, we would do it here, and if we drew them out, they'd be touching two different functions, right? So it would work, but then once you get up here, you could draw one like this, and then it's hard to tell because it's not a perfect graph, but you risk the rectangle up here touching only this function. So we're going to look at our vertical rectangles instead, and if you drew out a whole bunch from here, 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 you can see they'll always be touching two different graphs or two different functions, and that's exactly what we want. If we look at this one, it's touching the one function and the bottom is touching the other. Here it's touching this one, at the bottom it's touching this one, and same for all the others. So in this problem, it's best to use vertical rectangles, and that's what we're going to do. Now remember, when it's a vertical rectangle, if you continue this vertical line, it cuts through the x-axis, and that means we're going to be using, our bounds are going to be a relation to x. Alright, so let's write down our formula to calculate the area underneath this graph. So it's going to be from a to b, and it's going to be our upper function, which we call f of x, minus our lower function, which we call g of x, times dx, right? It's dx because we're using x. Okay, well, because we're using x, we know that the beginning here is going to be our a. My Sharpie's dying, I'm going to have to get a new one. And our ending point here is going to be our b. And our upper function is the function that touches the upper part of our rectangle, right? So let's say this is our rectangle. Well, y equals square root of x plus 4 is touching the top of our rectangle, so we know that is our f of x. So let me just write that down. You don't have to write this down for each one, but I'm just trying to illustrate it for you guys. And then the function touching the bottom of our vertical rectangle is y equals x plus 4 to squared over 8. So that's our g of x, that's our lower function. X plus 4, all this squared over 8. Alright, and now our a, we can see it's already marked for us. Both these functions intersect at minus 4, so it's given. And if you see b, it finishes right on the x, or on the y-axis, which is x equals 0. So we know that b is actually 0. So now we can write down our formula to calculate the area between these two curves. So we have a equals minus 4 to b 0, and we have our upper function, which is the root of x plus 4 minus, and it's important to put a parenthesis and then put in the function, and that way you'll make less mistakes. So x plus 4 squared over 8. And dx. Don't forget that dx. Very important. Remember, this is the width of your imaginary rectangle. This calculates the height. And the integral adds all the infinite amount of rectangles from point A to B and adds them all together, so you get the complete area of your whole of your between the two functions. And that's it. I'm not going to solve it like for the other ones, but if you wish, I believe the answer is 8/3. So if you calculate and you get a different answer, you probably did the integral wrong somewhere. But because we already set it up and this is correct, just double check your integral. Alright, thanks.